Hello, my name is Everett Richards, and today I'll be presenting my project for Computer Science 596. This is a blockchain application that implements a voting system on the decentralized blockchain network. So, without further ado, I'm just going to run through the basics of how this system works. This is just a general balloting system that can be used for any number of applications. I have this smart contract code here, and it's about 200 lines. It's got all sorts of stuff with the modifiers and whatnot. So yeah, we got lots of functions for anything that an administrator or user would want to do. So the main idea of this project is you have an administrator who runs a ballot, then you have a bunch of users who can interact with it, and the administrator just gets to decide the general flow of the election, like what gets to happen when you're going to move on from candidate registration to the other stages. So first, I'm going to just compile the smart contract, and it should be up and running. Okay, now I just need to connect it to Ganache, which is where I'm hosting the local blockchain. So I'm going to select my account bank here, just let it load. Okay, so you can see that the balance has gone down because it's already been used just from testing. So I'm going to connect to Ganesh and just deploy this thing, hope it works. Okay, so it worked. Now I just need to keep track of the contract address. Now I have, now the last step is to get a website up and running. So I've made a website using some HTML, some CSS, and JavaScript is the main part. That's how I interact with the Web3 library, just to send functions and commands to the smart contract, which is hosted on Ganache from the Remix IDE. So what I'm just going to do is I'm going to host a local web server just so I can get all this running. Awesome. And I'm just using a Python command here to get the server running, but the actual Web3 and everything is being run on JavaScript in the website. So I'm just going to pull up a web browser, go to localhost 8000, and here I have the application. So I'm going to create 4 little clients here. I'm just going to pick an address for each of them. Since I used this first address to deploy the contract, I'm going to just use 0 for my administrator because that's the it corresponds to the address of the user who created it. So basically, this the JavaScript file just requests a list of all the 100 addresses that are in the Ganache database, and then it just allows you to pick one by specifying the index. So we have that. Now you just put your name in. So I'm going to put admin. Then on each of these little clients, just going to give them names using the regular conventions from the class. Just call them Alice and Bob and Charlie. So now I'm just putting in the contract address each time so that it knows which one to connect to. So now I have 4 little clients running here. So the administrator, they can view a list of registered voters, which should be empty now. So I'm just going to have each user register to vote. So you can see they're not registered. You register. Now they're registered. And now that's done. So you can see a full list of registered voters. Now is the nomination phase. I'm going to have Alice here. She's going to nominate her. Oh, sorry. The administrator. See, this is actually proof that the that the function modifiers worked in the smart contract, because I tried nominating someone for candidacy despite the fact that the election was not in the candidate nomination phase yet. So the administrator has to change the stage to nomination. So now this user, Alice, is going to nominate herself. And then this third user, Charlie, I'm going to have him nominate Bob. So I'm going to copy the address, nominate him. So Charlie's not a candidate, but Alice and Bob are. So now that that's done, I'm going to go to the next stage, which is the voting stage. So you can see a list of candidates, and anyone has access to that, of course, just so they can see who they're voting for. So I'm going to have, I'm going to have Alice vote for herself. And then I'm going to have Bob, let's say Bob votes for himself as well. And then, let's see, the tiebreaker, Charlie's going to vote for Bob. So you can copy Bob's address, put that in there, cast the ballot. Okay. So now everyone's voted, so we can go to the next stage, which when I call this function, when it goes to the last stage, which is results, it automatically tabulates everything. And then you can just use these functions, get full results and get winner from any client to determine who actually won. So this one, the get full results, just shows you how many votes each candidate won. So if you remember, Alice voted for herself, and then Bob and Charlie both voted for Bob. So Bob has 2 votes, Alice has 1. So if I do get winner, you get Bob, which is exactly what we would expect. So yeah, and again, anyone has access to that. So a couple kind of drawbacks that I have with this program is, for one thing, anyone can register. If you have any address, if you can connect to the blockchain, then you can vote, meaning that it's not really secure. So if this were to be implemented in the real world, you'd have to actually have a way of verifying users. Also, there's no time constraint set in it. So in theory, the election could go on forever, or as long as the administrator wants, which means that the administrator could also be tricky and try to speed things up to their advantage, which kind of defeats the purpose of a decentralized application. But in future applications, you could use something like reading the block number and transaction hash and all that to verify the certain amount of time has passed, so that once someone has initialized a contract with a specified amount of time, it's just up there and people can vote, and there's nothing anyone can do to interfere with that, which is kind of the point of this decentralized application. But other than that, other than those little concerns, works pretty smoothly. So that's the gist of this project. So thank you.